So welcome once again to everybody to this webinar on sheet metal and plate work that will be happening on Advanced Steel. My name is Pierre Geoffrion. I'm Business Development Manager for Western USA. I'm here on the line with Benoit Lalonde, Application Specialist for Advanced Steel. So essentially the goal of this webinar is to show you guys a little bit more functionalities on sheet metal, plate work, and also to show how it's easy to complete a set of drawings and how it's possible to do this under 20 minutes. Essentially, the agenda for today would be to go quickly through a corporate presentation of Greatech, who we are and what we do, undergo a live demonstration on Advanced Steel, and showing a few examples and sample projects of plate work and sheet metal. Now, for more than 25 years, Greatech has provided to over 40,000 worldwide users some software for the structural building industry. Essentially, we develop our own software, we distribute it, we support it, and we also develop customized software for specific players in the structural and construction industry. We estimate at more than 600,000 the number of projects that have been built and designed with our software around the world. We have 14 subsidiaries around the world and counting as well, through Canada, Czech Republic, France, Germany, Italy, and in the US, of course. We also count a number of resellers, some value-added resellers that not only distribute our software but also support it. Our users typically are engineering and design offices, some detailers, erectors, fabricators. Also, some architects use our software, and schools, universities do their teaching with our software. Greatech has its own BIM technology, so essentially we can cover the whole scope of the structural project and at the same time connect this BIM technology to other multidisciplinary BIM solutions such as Revit. On the structural side of things, basically undergoing a preliminary design, undergoing simulations, analysis, generating drawings and reports automatically, generating reinforced concrete detail drawings, steel detailing, detailed drawings, of course, through Advanced Steel, automatically generating the NC fabrication files to feed the fabrication machines and beam lines, laser cutters, etc., generating detailed bill of materials as well. And this structural BIM technology is essentially enabled through our Greatech Advanced suite of software, which is composed of Advanced Design Analysis software, Advanced Concrete for concrete detailing, and of course Advanced Steel for steel detailing. So let's go down a little bit more in detail on the plate work and sheet metal subject of today's webinar. It is possible to undergo many different types of projects for sheet metal and plate work inside Advanced Steel through a full set of dedicated tools. We have, for example, folded twisted plate functionality, conical folded plate function. We have many templates for shapes and cutouts as well. I will leave Ben Lalonde now, Application Specialist for Advanced Steel, to do a live demonstration on the software.
Thank you, Pierre. So as Pierre mentioned here, we'll be doing this webinar on top of Advanced Steel. And basically what you're seeing here on your screen is the layout of our commands and icons being used to create our multiple material in the 3D environment, and then we'll go and process some drawings. So basically from the ribbons and tool palettes, we'll be able to work those both together. We have under objects specific commands to create whatever members. We have all our plate works here under plate, so we'll see a couple of functions inside these plate functions here. And also under the tool palette, we have some plate features and beam features here. So under utility, we'll find here also great CAD commands like basic CAD stuff like lines, circles, rectangulars, arcs, and all. We'll be working with those to create our plates. This first example I'll do here is to create a conical folded plate. This is the way we name it. It's basically creating some kind of a chute hopper with different shapes. So I'll just be defining the center radius of this first circle here, and we'll give it a specific diameter. And then from here, we'll just go and create a second polyline. So let's go and create this square shape here, just above it, and move it up. So let's take this one here and just move it up, let's say 60 inches up. And we could have the flexibility with this tool to change whatever shape we want. This is not a regular square. It's something with a specific angle in this corner here. Let's do a second assembly also. Let's create another circle. So again, from the initial insertion point and put it larger. I'll just take this second one here and drop it down. So let's drop it down again, 60 inches. And basically, I'm building the shapes, the outer contours of the plate work I'll be needing. So once this is all done and processed in the model, we'll go here under Objects, and here under Plates, you'll have what we call the Create Conical Folded Plate. Quite easy process to do. We only need to select those two outer contours. So selecting this shape here and this circle here, we'll create this first plate assembly. This system here, the command is asking me to have how many corners we want, how many bends or how many cuts per corners we want, the plate thickness, the reference according to these two polylines. Do we want to have these plates inside, outside, or in the middle? And say OK. And we have this first plate assembly created. Let's do this second operation on those two circles. So I'll just go here and select this first circle here, and the second one at the bottom. And putting more than 8 facets per corners will increase the precision on this plate. So let's put 50. And as you can see, all these red lines are corresponding to bends created on that plate assembly. So as you can see, I'm working now under a wireframe. We could change the presentation of this, going more under a realistic presentation, and all the plates are created upon what we asked on those previous shapes. So it's a quite easy process, pretty flexible on what we could create on shapes. This can be used as, creating chutes, hoppers. If you're having similar, shapes, you'd be able to create some plate girders. So that's all part of that. Let's go and change and create another type of plates here. We'll be joining those two plates with a circle plate. So going back to Objects, creating a new function here called the circular plate. So let's apply this and define some outer diameter of this plate. So in this case, I'll just put, let's say, 96 inches for the outer contour and 80 inches for the inner contour. We have, of course, the controls on the thickness of this plate. And we'll say, OK, you'll see here in the corners that this round plate has been processed in one step, creating all the cuts and all the rounded off corners to create this. Let's call this a donut plate, basically. So I'll just take this one here and copy it down. On the plate thickness we have, so 1/2 inch. So now we have those two plates, one above each other. So it's a quite easy process just to go and apply those commands around the model. And then let's say we want to join those together. We have great tools also on the bolt creation. So under bolt creations, you have various options, and this circular one is quite neat to use. I'll just go and select those two plates and define the center of this bolt assembly, and we have the controls on the location of this. Or you could just go and type in the radius of what we want. Let's type in the good values, and we have multiple bolts showing up on that specific radius. Now we have this bolt window showing up on whatever type of bolts we need. Change this whatever type, the steel grade. If we need nuts and washers, we could define different bolt assemblies from here. The bolt diameter, the sizes, the numbers of bolts going on that radius can be easily changed here. So we have 20. Let's say we want to go back to 10, so we'll have less bolts. So we have the controls by the center of those radius creations. So naming, we'll see this later on. Each of our plates will need piece marks. We'll process those and create drawings. So in quick steps, we created, two conical folded plates and round plates to connect those. We have this great other tool that we have is called the conical folded plate. And again, this one works with curves. We'll just go here and use our C-line commands and create nice and fancy curves. And this type of plate work can be used on specific roofings that has, multiple, curves to it with slopes. And you'll see that we'll be able to shape the plate. And I'm changing here the curve on the second one, so you'll understand that we'll create something with plates that are twisted. So going back to the twisted folded plate and just applying in onto those two specific lines. Again, the system here is asking me how many bends per corners we want. Let's increase this. Let's say 40, the plate thickness, 0.25, and the reference. That's all creating now the plate assembly needed for merging those two curves together. So if I could show you a little bit better, those two curves are not the same, and we were able to create nice plate work from there. All right, let's go and show you something different again from another command called the folded beam. So by creating the outer contour of what we want to do here, so let's create something with a shape. And this type of work here can be very useful for light gauge steel and creating lintels, gutters, so everything that's created from plates. And so I'm just defining the outer contour of what I want, and now specifying a point, a working point, I'll be able to insert this beam in. Now from this tool, we'll be able to add some radiuses in the corners, change the positioning of it, just like a regular beam that you'll find in advanced steel. So again, it's a quite easy process on what we could do here with those plates. So that's another type of plate work we could do. Of course, the beam features on this can be workable. So if I go here under my tool palette, we have beam features. We could, create a shorten on this beam quite easily by just adding features and saying the distance I want to have a short up on. Creating simple plates are there also. Of course, we have create plates. There's different ways of creating plates. One starts by 1 point, 2 points, or multiple points. I'll just go here and create with 2 regular points here, defining the width of it, the positioning according to the justification I would need. Piece marks, we'll see this later on. And again, from the tool palette, just like for that beam feature, we have some specific for plates. So I'll just go here and add let's say, circular contour onto the center of this. And again, we could just go and change quite easily this diameter just by editing the values. We have also a tool for cutting those plates. I could divide this plate by 2 points. And basically, let's take this from the midpoint of this plate here. 2D midpoint on the other side, so we'll be defining a cut on those two specific insert points. So we can see now that this plate has been divided, and we could go and continue adding more features to it. So defining fillets in the corners. Again, we have controls on, just go here and edit the values on that fillet, on that radius. Creating a quick chamfer in the corner, easy process here on just clicking in the corner and then just define and pick whatever dimensions we need. Now that we have two plates, features on this one, we could create a bend plate out of this one if we want. So from this tool here called Create Folded Plate, I'll be picking those two plates, and it will create this first bend, joining those plates together, and of course, I'll be having the capability of changing the angle of this specific plate work. Now, all the features added to a plate will follow the specific angle requirements that I have. All right, so in addition of the plate work, I would like to show you something else also on pipe work. So working with some pipes would be quite easy. I'll just go here and process a short column. I'll just rotate here and create this first column of pipe and put one that would be perpendicular to it. So again, I'll just insert a pipe with a midpoint to it. And let's change the sloping of this. We'll be working also with the beam features where we could go and create the cutout we need from this onto the other pipe. Okay, small mistake here. I'll just reinsert this second pipe that was not on the good location. I'll just go and zoom in on the nearest point on this red line to make sure it's on it. This is good, and we'll just push it up. Now using the element contour option, I'll just define on which member I want to create this cut. Let's say this beam according to this one. And now we have the cutout needed on my pipe according to the other pipe. We'll do a drawing creation of this also. So now that we have all the plate works needed, we could see that it was very easy to create all those within the advanced steel commands that we have. Now we'll go more on the drawing creation. All right. So to create drawings, I'll just go under my output, create a quick numbering, adding piece marks to all of these members here, the plate, and then create specific drawings. So under quick documents, we would have under our user two specific ways of creating drawings. I'll just go under drawing styles, use something that would be giving us an unfolded detail of this material. So I'll just say use on this process and select the material in which I want to have those drawings. So this one, those two conical folded plates, and let's take the twisted folded plate here also. So picking a sheet size, drawing number would be 1000. The drawing is done in process. All right, let's go and create a drawing for another one. I'll be doing the drawings here and show you those a little bit later. So again, quick document, I will go and apply this other type of drawing style needed for that member. So that would be the folded beam option, showing us unfolded details and all the dimensions needed for that plate assembly. Again, just going and picking a specific sheet size for this, drawing 1001, and that's good. For the pipe, let's go and create the drawing now for this pipe. We'll select this pipe, and having under special parts the tube with the template. So we'll basically be building and creating a drawing of an unfolded detail of that pipe. So we create a quick template for the shop. So I'll pick a C5 sheet. The last drawing maybe we want to create are the round plates here. So I'll just go and select those and pick a specific drawing process, again from single parts, and having something with curves and giving us radius. I'll just go and apply this one simple curve beam. Everything is done in process. All right. So once the drawings are all done and created, we could run also the DXF. We have great options here for creating DXF for plates. We would just go and create a selection of those plate works, and creating DXF options plates would be coming from here. And we'll see in a few seconds where those drawings are going, where the DXF plate information is going. We'll find this under our Document Manager. All right, let's go now and create a material list of this plate work. We could select all the plates and going under Create List, and this will basically give us a nice external list of the materials that we need required for fabrication. So running this Create List, and we'll have a multiple list showing up here on our right for external lists. So these are lists that you could send out to fabricators that will need to order the specific plate size needed to create these plate assemblies. We would probably pick here this plate list command and just apply it to that selection I just did. So I'll say use, and this will create this report showing me, well, first the piece marks, description, the steel grades, the lengths, of course, the width, the plate thickness needed, weight, surfaces, and all the information that you're seeing here can be customized according to what you need to show onto these lists. We have great bill of material editors where we could customize these. Now these lists can be exported into different types of files. You could export this onto an Excel sheet, Word, HTML, or PDF. I'll just go and save this to show you again where this specific list will be going. All right. So once we've done the DXF, the list, the drawings, we could go now under our Document Manager. And this is basically doing the link between your 3D environment and whatever you process, whatever items you process from the model. So you'll have here drawings, you'll have here your list, that plate list is here, and under DXF, you'll have all your DXF. Now this manager will do the link. If there's any revisions during your modeling process, you'll have these to show up under a different status called Update Required. From this tool, you'll be able to force some updates, create revisions, flag those issued for shop, and of course, you could open those. We have this preview button showing us the preview drawing that we're going to be opening. So let's go inside this first drawing that was the 3 unfolded details, and we could see the final result of the drawings. Pretty nice drawings here showing us dimensions of the outer contour of it, having the plate, plate size needed to create this. Also, if I zoom in better, all the bending lines in red showing up with the angles between those two lines. Well, all those red lines, you'll have the angles required from one to another one here. So having a complete unfolded detail of all that plate work we need. So we have those 2 conical folded plates, and this was the twisted folded plate. So having the title information and all the information showing up in the bill of materials, regular information having piece marks, quantities, descriptions, lengths, and all. So it's a complete drawing for fabrication. I'll just go here and close this drawing to show you different ones. Going back again to our document manager, let's pick another drawing that we just created here. Preview. So that's that folded beam option. Let's go here and open it. See the final result, and you'll have here all the dimensions required to fabricate this. Of course, inside these drawings, you'll be able to move your dimensions around. It's quite flexible on what we could do inside and modify these drawings that we want. Again, you'll have, if you want, the unfolded detail of this plate assembly and the information in the bill of materials. All right, let's go back and go to our details again. Might see something else. Let's check that pipe, that unfolded pipe here. Let's go under drawing 1002. Open this, and we'll have the unfolded detail of the template needed to create the cutoff of this pipe for the shop fabrication. So basically, if you're printing out this drawing here, scale 1:1, you'll be able to take this paper, do your own cutout, and give this template for the guy in the shop so he'll be able to create the cuts on that pipe. So another automatic way of creating drawings for complex drawings here. So, in a few minutes, I was able to create some complex plate work with features, adding bolts, doing drawing creations, DXF files, another external list, and this is why Advanced Steel is a great tool to create plate work. This is pretty much what I wanted to show, so I'll pass the mic to Pierre for the final conclusion of the webinar.
Thank you, Ben. So essentially we saw several functionalities on plate work and sheet metal. If you'd like to do a little bit more reading on the subject, you could log on to thegreattech.com. Right now we are broadcasting the web page where you can basically click on the Advanced Steel product and scroll down, and you'll find a page on Advanced Steel specifically for sheet metal and plate work. One thing to keep in mind as well is that Ben was showcasing some simple models, but it is possible to undergo and model very complex projects inside Advanced Steel for plate work and sheet metal. Right here is an example of this, of a more of a project fairly large in size, incorporating a lot of those sheet metal and plate work functionalities. Also in the oil and gas field, we'll find a lot of a lot of plate work happening around the miscellaneous steel, or plate work for chutes, hoppers, and different elements like that. If you would like to know more about the subject, if you're an existing customer and you've found several functionalities very interesting and you don't master them, we obviously offer training on these functionalities. You can contact us through sales@greattech.us or sales@greattech.ca. We offer training on both the web-based or on-site as well. If you are not a customer of Greattech and would like to know more about the overall software or other features, either on miscellaneous steel or the structural part, you will be happy to address your questions as well, and even schedule another demonstration. So thank you for your attention today, and feel free to reach out to us for anything else. Bye-bye.